Now, boys and girls, here is what you get when you join the Secret Squadron.
Every forklift comes from the factory with a nameplate or data plate. By law, it must be present and legible. It is very important because almost all the critical operating data is on this tag. For example, how much can the forklift safely carry and to what heights? Does the forklift lose capacity as it goes to maximum fork height? How does load center affect carrying capacity? What type of fuel does it run on? Gas, diesel, or liquid propane? You obviously would not want to put diesel in a gas engine. If the lift truck is battery-powered, the data plate tells what voltage the system is, such as 36 volt or 48 volt. It also tells the proper size and weight of the battery, which is very important to safety because the battery not only acts as a power source, it also acts as the truck's counterweight. If the lift has pneumatic tires, it tells proper air pressure, as this greatly affects load stability when operating on rough terrain. Furthermore, if the forklift has attachments such as a side shifter, carton clamp, or paper roll clamp, the data tag will reflect that and adjust the load capacity accordingly. Finally, if ever you add a new mast or any other attachment, a new data plate must be requested and approved by the manufacturer and installed by an authorized dealer.
One of the most important things you need to know about your forklift is how much it can safely lift. This information is listed on the data tag as previously discussed. The key takeaway here is that the capacity of the forklift is not a constant. Just because the lift has a base capacity of, say, 3,000 pounds, that does not mean it can lift 3,000 pounds under all conditions. It largely depends upon where the load center of gravity is. As a general rule, as this is just a general rule of thumb, consult your owner's manual for specific data, but for every inch that the load center of gravity moves out from that 24-inch reference point, the carrying capacity of the forklift is decreased by approximately 100 pounds. Why did the engineers use 24 inches, you ask? Many different size pallets are present in industry, but your typical run-of-the-mill pallet is a standard 48 inches in length. Take half of that and you have 24 inches. Most forklifts, with some exceptions, are rated with their load being a nice square cube of 48 inches by 48 inches, thus having a 24-inch load center as a starting point. If you've been paying attention to the operator in this film, you'll notice that he has been lifting this crate by the side, not lengthwise. By doing so, he has kept the load center well within that 24-inch rating, putting into practice what we just discussed.
Some manufacturers' data tags do an excellent job of graphically showing what happens to load capacity as the load center of gravity changes. Here is a real-world example of just that. We're going to focus on the bottom curve, the one indicating a 196-inch mast. As you can see, a load that has a 24-inch load center has a full 7,000-pound lift capacity. Now see what happens when the load center of the load shifts out to 30 inches. You have 6,000 pounds of capacity. And at a 40-inch load center, you have a 5,000-pound capacity. And finally, at a 60-inch load center, this forklift has just a 4,000-pound lift capacity remaining. A loss of over 3,000 pounds of load lifting capacity over a span of just 36 inches, which follows very closely to that 1 inch equals 100 pounds rule we spoke of. Warning: in the real world, picking up a load the wrong way can easily add 36 inches to its load center, like when you pick up a load lengthwise instead of by its side.
One final note on capacity loss. Not only can you lose capacity with a shifting load center, capacity can be lost vertically too. Lifts with very tall masts, such as this quad-channel mast with a 227-inch lift height, can lose capacity substantially by simply having their forks raised. Study this chart closely. It retains its full 3,500-pound capacity from ground level to 156 inches. But from 156 inches to 227 inches, it loses a whopping 800 pounds of lift capacity over the 71-inch span. In this case, a drop from 3,500 pounds to 2,700 pounds. This is yet another reason why it's critical to keep the heavier items at lower elevations.
Another key item indicated on the data plate is what designation the lift has in terms of its operating environment. This lift has a double E rating. The double E designated units are electrically powered units that have their electrical motors and all other electrical equipment completely enclosed, allowing it to operate in hazardous areas where just an E rating may not be safe. Usually companies that operate in areas with explosive, flammable, or combustible vapors or dust have to worry about this. There are 11 designations in all. For a complete description, along with a mind-numbingly detailed explanation and listing, you can go to OSHA.gov under section 1910.178 and refer to Table N1.